these slides are laid out. So I'm going to leverage them instead of just doing my own ES6 slides. But as I said, there's at least one topic that I don't think is covered in enough detail here. It's just sort of glossed over. And so we'll probably spend a little bit of time after we go through these slides talking about that as well. But we'll get started with this first. Hopefully people will hop online if they're remote. And just talking about ES6. So if people want a little background, when did ES6 get standardized? Let me double check here. ES6 history. So 2015, which is quite a ways ago now, but it feels like it was just the other day. But that's because for a long time, JavaScript didn't really move forward. Like it moved sort of fast, but not a lot of changes up to 1999. And then in 2000, there was a whole bunch of stuff added with ECMAScript 4, except it didn't actually get used. That got thrown away. It was this whole very complex standard that was going to be changing how JavaScript worked, and it just sort of got tossed because it was too much of a change. So instead, there were some minor changes from 3 that became ECMAScript 5. And that just sort of hung around, I guess, around 2009. And then 6 didn't come around till 2015. And I think pretty much all browsers, except for, say, like Internet Explorer now, fully support 6, except for all of the module syntax. Some of them, I think, still need some external support for handling modules. But I think all of the other features are baked into the browsers for 6 now. And after they did ECMAScript 6 or ES6, they changed to a yearly cadence of updates for the language so that it doesn't get stale the way that it did before. So now JavaScript gets updates every year with, usually it's just small little tweaks that they're adding to the language every year. Like I can take after we walk through this, I can look at some of the stuff that came in 2018, which I think was just really tiny changes. So that's about all. This is the gentleman whose slides I'm stealing, so let me stay on that for a second. All right, so let's talk about just some of the new stuff in ES6. Again, none of this should be too challenging, as the majority of this is just syntactic sugar, which just means that's one of the reasons I like this, is it shows you how to write it in the existing JavaScript that you've been writing, and then how you would write the same thing using ES6. I'll talk a little bit about if there's any real differences between them, but most of it is just to make something easier to write. So one of the first ones, and we started using these with Jest, and I said don't worry too much about it, is the concept of arrow functions. So we've been writing our functions traditionally like this, with function, and then the arguments, and returning something. Except sometimes when, for example, in those Jest examples, you don't really have all of the, what do I say, ceremony around the function. You don't care to give it a name because you're just putting it in a place where you want to use it once and then sort of throw it away. And you don't really care to be able to call it by name outside of that context. And this can just add a lot of extra boilerplate that you have to write. So instead we've got this sort of simpler syntax to be able to write very basic functions. So this is just saying, here's a function. Here's a function that takes a parameter of x, or an argument of x, and then it returns x times 2. And some of the stuff I don't know if it'll show it here. So with arrow functions, there's a few shortcuts that you can use, but you don't have to. For example, if your arrow function, anyway, let me step back for a second. The way you write it is just your arguments. You don't have to say function, and then an equals sign and the greater than arrow. So that's why it's an arrow function, right? It's making an arrow there. And if all you're doing is returning a value directly, you're not doing anything beyond just a very simple computation. So for example, the add and subtract, and I can pull that up from the other day and rewrite those if you guys want. Then you don't actually even have to put parentheses around it. You don't even have to say return, because if your arrow function only has one expression in it or one statement, it will by default return the result of evaluating that statement or that expression. So it evaluates this and just returns that automatically. So it didn't have to have any of the extra ceremony of the, the curly braces and the return statement. Now you can use those. If your arrow function has more than one statement in it, takes a few things to compute the result, and then you still want to return something, then you have to use the curly braces, you have to have the return statement in there, etc. But by default, if you got something very, very simple, you don't have to write it out in this more complex way. So this is another example of working with some of this stuff. Let me see here. Yeah, this is an example of the existing like function syntax, and you can see here's the function that wraps, and this is sort of a nested set of logic. I wouldn't necessarily recommend writing the code this way because it makes it a little hard to read, but you're going to encounter code written this way. Some people really love being concise and not assigning variables. And so you'll see people nest stuff like this. And so we've got a function that then just invokes this other function and does a little bit, etc. But because this function never returns anything, and this doesn't actually have a return, nothing gets returned from these, right? Because these are traditional functions. And if you rewrote those using this arrow function logic for, let me see, for this one right here, at least, which takes a function, then it's actually going to be able to, something else off here. Oh, ignore this. This is getting into something deep, sorry. I thought this was just another example of that. That gets into how this works inside of arrow functions, which is a little different. We will talk about that when we get into React. Yes?
Is there a reason like ever for us like what would be the best usage of this? Like in the sense of like, is this like a complete new way of doing functions where we can stop doing functions, or it's like we use this during certain?
So I'm introducing it for a couple reasons. One, because you're going to see a lot of this syntax. As we start digging into React, this is a very common syntax to encounter. So arrow functions I want people to be comfortable as they're encountering this stuff. Two, there is a specific use case where it makes sense, and that's what this is getting into, but it's really hard to sort of talk about what happens, where I'll probably have a more focused session on that, but I want to talk about objects again a little bit when we do that. And the specific context is, I don't know if people remember, it's been a long time since we've discussed this, but whenever you're running a function or any bit of code, it's in some given context. So for example, if you've added a method to a class, you can use this dot to access other properties of that class usually, unless you pass that method around in a specific, or unless you reference it a specific way, in which case your this context will get changed to be, say, the global context. One of the interesting things about arrow functions is, unlike traditional functions, they're bound to their this context at the time they're declared, as opposed to dynamically like normal functions, which means that this context for an arrow function can never change. So that is one case for it, which the prime example of when you would use that, again, we haven't talked a ton about it, is callbacks. So if you have code that, we did do some callback work a while back, but if you have code that is a callback that says like, okay, go do this, go write all of this content to the disk, and when you're done, call this function again, right? And that's this asynchronous bit of code where you don't know when that function is going to get called. So all you can do is give it a function to say call. If you're using traditional functions as opposed to arrow functions for that, which is, I mean, it's fine to do, but that traditional function won't keep the context of where you declared it. So you may have to do some extra work to make sure it has a reference to this. Whereas an arrow function will be bound to its context. I'll try and make them more, I mean, this is showing that. So let me see if it'll make sense if I walk through this. So let's try and walk through what we have here. And maybe I could even, I can't copy it from here, but if we're looking at what this code's actually doing, we're creating an object called Jack. And on Jack, we're putting two properties, name, or three properties: name, friends, and a method that will print our friends. So these are just a string and an array. Print friends is a function that inside of it attempts to look at this dot friends, which is referring to Jack because that's how it finds the context of this that's on this object. And then just says for each one of those, pass the friend in and log the name where it's like Jack knows James, Jack knows Steve, right? And if you notice what actually gets printed out if you call print friends is it would print out undefined knows James and undefined knows Steve. And the reason for that is because of that context that I'm talking about. Since this is a function being declared here, and it's not a method like directly on the way this is written, this function can lose its context of this, or lose the context that you might think it would have easily. Like if you've written like Java or really any other programming language, this will make no sense to you because no other programming language that I'm aware of works this way. So this is a really big stumbling block because those all have the static binding. So this will always refer to what you want it to refer to or what you might think it would refer to. In JavaScript, it's dynamic. And there's some really cool things you can do with it being dynamic. It makes it a very powerful tool in your language, which I could probably go back to one of the videos where I talked about how to do some of that, where I changed the object that a function was referring to and it changed what printed out. I don't know if people remember that, but it also makes it really hard to work with and reason about if you're not comfortable with that concept. And so this is an example of swapping it, right? The only change in this is an arrow function here instead of declared with the function keyword. And as a result of that, when this arrow function gets declared, not when it gets invoked, is when it's bound to this context. And since it's declared inside of this function that already has a correct this reference, it maintains that context. So then it's going to know the right context that you would expect when you're invoking it. So I mean, this is a concrete example of when you would use that. Some people have decided that they just love arrow functions and they'll write them instead of traditional functions just about everywhere. I think there's pros and cons to the different approaches. So I don't think that there's like, oh, this is the only way to write them, or this is it. The thing I would suggest is even if you do end up, like if you keep writing JavaScript and you're like, oh man, I really just love writing arrow functions and I want to use them, is at the very least, most of the time, assign them to a variable so that because when you get into more complex bits of code and you are debugging and all you see is, I don't even like these like this, all you'll be able to see in the code stack there is function, and you won't get to see a name for it when you're looking at it in, say, Chrome DevTools. And so it might be a challenge to figure out exactly what's being called, whereas when you name stuff, it's much easier to pinpoint what's going on. So that's something that I probably wrote a lot of arrow functions when I first started using them, and then I was like, man, I really miss being able to have names as opposed to just function, anonymous function all over the place. This is just the same sort of thing, except it's showing an asynchronous thing where this is doing sort of like what I said, except instead of right into the disk, it's going and fetching something from a server. And so this dot name is going to be wrong. Here it's not going to have the right context again because this function is declared inside of another one on this object and it's bound dynamically, whereas this one would have the context you would expect. So that's really where arrow functions end up excelling, is maintaining that context the way you might expect. But you can, let me see, do I have any of it up? I don't think I do. I think I'm going to need to open a new, I'll just change this window. So if we went to the classwork code that we've already done, for example, arrow function type work, or writing something as arrow functions can be really simple. If I wanted to change these ones, since they're very, very simple syntax, they're just a return, they're one computation. And I wanted to write these as arrow functions instead. I'm gonna just comment this and then replace it. Or I'm gonna say var add, this is me giving it a name at least again, this arrow function that takes A and B and returns A plus B. And we have tests around this, I believe. Let me double check. So we can see that it says one skipped. I don't know which one that is. But we can see that the test passed, right? So I rewrote this in this sort of concise syntax. So that's another place where you might use arrow functions, is if you've got a very simple computation that you're writing. Not if you're writing a big complex function, but if it's just this one simple thing that you're doing, oh, all I'm doing is, you know, dividing by something or squaring or, you know, anything like that, you can easily rewrite those as arrow functions. So, you know, then we could do like subtract the same way. And I have to get rid of this because I can't have two things defined with the same variable name, or else it will have problems. And I could do multiply if I want. Oh, I missed something up here, didn't I? Missed my arrow. Get rid of that and save. Oops, I'm not still running my tests. So let's check our tests. We should hopefully see all of the tests still run or still pass just like they were before, right? So that's sort of showing you that at its base level, it's really just sort of the same thing. We're not doing anything magic or new. But if I, on any of these, if I put, let me switch this to watch. I think I defined watch, right? I can do it this way. Should work. So we'll see the tests continue to run. There we go. On any of these, if I change it so that I have these parentheses around it, then at that point, you would typically only do that if you have more than one line. But now I have to add a return statement to my arrow function for it to return that value. Otherwise, it's going to return undefined. Make sense? Again, you probably see a lot of this. They're very popular for callbacks or other things, which is one of the reasons to introduce them. There's one other small simplification that can be done to these as well, which is if we have, you know, like a square one that says A and just returns or A squared or something. If you have a single argument here, you can actually get rid of the parentheses and sort of, oh wait, I didn't, there we go. If you have a single argument, you can get rid of the parentheses and just write it like that. I, just out of reference to sort of having a consistency and being able to read them consistently, I usually stick with the parentheses so that I don't, it's easier for me to read my bits of code, but the other approach works as well. All right, let's see what else we have. So one of the other things, and this we haven't talked about at all, but this goes back to objects. Now, who's written in a different programming language before, like an object-oriented language? Okay, this is gonna probably make you feel a little more comfortable than the way that we were working with objects before. But before I get into it, let me reiterate, this is just, again, syntactic sugar around how JavaScript objects actually work. So it might make you feel comfortable, but it's still a little bit of a lie if you're thinking that they're working the same way as objects in other languages. So, you know, we've written objects several different ways. We've done like object.create, and most of the time we've just done object literals where we've just done the curly braces. Well, now with ES6, you have the ability to create a class, which is very much like a class in any other programming language you've encountered. If you haven't seen these in another programming language, this is, if you remember the object, what did we have? The sort of factory functions that returned an object. You know, those are really simple. We don't have to have anything complex for one of those. Do I have an index here? I've got an index. Let me open index and we'll just throw some stuff in there while we're showing something off. Like a factory function is really simple. It's like function car factory, I don't know, right? And you could say like we've done, like make, model, year. And typically all that would do is return like a car that has a make of make and like a model. That's the model they passed in, and a year, that's the year. And then you could always call that to get an object, right? Like var my car equals car factory Mazda 3 2007. And then you've got, you know, exactly that. We've worked with this a fair bit now. We're going to come back to this in a second. Console.log. My car dot model or make, probably be how I'd say it. And my car dot model, right? It's running the tests. Hold on, I don't care to run the tests. Let me just run. This may fail because I can't remember if index.js is still. All right, 2007 Mazda 3. So this class, you can think of it a lot like that factory function that we wrote, except this constructor is much closer to the factory function portion. This is going to get called when we new up an object of this type, and I'll show you working with that. Let me see if he has, he's got some right here. So I'll go over and look at that, and then we can talk about it. But this constructor, that's a lot like that factory function. You can see it takes a couple arguments, a name and an age, and then it just says this dot name equals, this dot age equals. And this about here, that's basically just creating a method on our object that can be called. So that's the same as adding a property that's a method on it. The constructor never gets called, like you don't have to call constructor directly. It gets called when you new up an object, which you can see right here. So created like a Jack, you got new person, and that's because that's our class name. And it passes in those two arguments. Now Jack.about prints out what we wanted for it. So this is a useful thing for people who are very familiar with other languages. And it's a useful way to have, create a lot of boilerplate around an object that you're going to be making. It's still the same type of JavaScript object. It doesn't change the type of object that you're actually creating when you do this. So changing this car factory, and I'm not 100% sure if the node on my computer will be up to date enough to support this. We'll find out.
JavaScript, other than like Jack, what is the utility of using classes?
I mean, again, this is another one of those that's very common to encounter now, and so I want to show it. It is nice if, like, React uses it pretty heavily. And it's also nice when you're going to be creating a lot of objects of a specific type, or you've got some very complex objects that you're creating, like, oh, and you'll see an example of this. This object inherits from this other object, and I need to get all of that figured out. This syntax makes that type of logic a fair bit easier to write out than if you're doing it using the traditional like object.create and then like .prototype and all of that syntax that we went through in the last class. This syntax makes it a fair bit easier to work with than using that version of the syntax. But yeah, we'll go ahead and convert this, right? So now I've got our car, and we're just going to make an object here. I got to double check my syntax. I don't write objects necessarily every day. I'm making a class, a car class, and now I'm going to have a constructor in there, and it's going to take a make, a model, and a year. I can just do this dot make equals make, this dot model equals model, and this dot year equals year. And then if I change this my car line, instead of using my car factory, I just do a new car. Let me get rid of my other output up here so that we're just seeing the one thing right now. There we go. Let's try this. We get the same output that we had before. You know, I didn't even have to change my console log that I was doing. So it created a car object the same way that this created a car or car factory did. It just used the syntax that people who are familiar with other languages are probably going to be much more comfortable with in terms of the constructor being called.
Some kind of shortcut that allows you to write all that logic with like all the input arguments, right? Not one element. It's not you have like 100 of those things that are is there a shortcut to make all that happen?
I'll show, I don't know if this goes over it. I'll show a shortcut. Let me, oh wait, hold on. All right, hold on. Fix my changes that I didn't mean to make here. I'm gonna copy this line. I'm gonna do both of these. I'll show a shortcut for at least the earlier version, like our car factory one. I'm just gonna make this my car one right now. I'll show a shortcut to make this a little simpler up here. There's not a lot that makes this necessarily simpler, but you could change. There's some stuff you could do, and I guess I can show that too because I think I'll show some structuring and destructuring. And that's one way that you could potentially make it a little easier. I don't think I've written it that way before. We'll see if that works. So we'll come back to this. But usually I would say you try not to have your objects be too large in the first place if possible. And so you would hopefully not have tons of things on it. Usually if you were doing that, it would be like a bunch of smaller objects that you've already created that it's being composed of. And so that stuff's being split out into a bunch of different bits of logic. So like a car, you wouldn't put everything about all the details of an engine, for example, in here. You would have that split out into like an engine object, which also has like, you know, a piston object and camshaft object and, you know, all these different pieces that sort of go together to make it. This is also another, I mean, I guess you could argue this is a way to do some of this as well. So here's this is that aspect of inheritance, right? If people remember, again, going all the way back, and I'm not going to dive into it, videos should be up, and we can talk about it if people want to, but this is how one object inherits properties from another object. So this sun object or class is saying, when you create an object from this sun class, we want it to inherit the properties from a person class as well. So the person class was right here. Now the sun, very simple, it has a constructor with name and age as well. And you notice it, instead of setting the name and the age directly, it calls this super function. What that's doing is saying, call the constructor of my, that's what this person is, my super class. So that's what that syntax means. Oh, this is the super class. This is a subclass. And call that and add those properties to this object, this person object. And then we also have a this.sun equals true, which is the only, this is a property that's unique to a sun object. So if we look here, it creates a sun passing in Jack and 22. And about also exists because it inherited this method. So it has full access to everything that was on this person. But then it also has true for sun, whereas Jack would not. And so if let me try and do a concrete example of something like that. I'm going to change this to just be vehicle. I hate using this as an example because it's not, this is the type of thing that creates bad object-oriented programming, but we're going to put a constructor on here, just like before, and this is going to take the same 3, make, model, year. I'm pretty much going to imitate what they've got. I'll call super, passing in. And the reason you have to do it that exact way is this is just a method, so all we're doing is calling it. We just get to call it using this super keyword instead of something else. Yes? Oh, I'm sure that they would have some stuff about it. Yeah. I would be careful again because, as I said, JavaScript objects are actually different than Java, or JavaScript objects are different than anything else. So this is where I'll get cynical or whatever. These classes are not an actual thing in JavaScript, the same as they are in other languages. So in another language, a different language, pretty much any other language, you can say, oh, what class am I a part of? But really all this is saying is we're creating objects of type truck, and it has no association with the class after it's been created. All it has is a prototype chain. So it says, oh, create an object of type truck and also an object of type vehicle that will be the prototype for the truck object that we're creating, and connect those two. Whereas in most other programming languages, when you have inheritance, it doesn't create multiple objects down this chain. It creates one object inheriting all those properties. JavaScript's like, create this. Oh, you inherited from that? Create one of those. Make it the prototype. Oh, you inherited from that? Make one of those the prototype, and on down.
So it's almost like that.
Sort of, yeah. Yeah. And again, we talked about that in the object classes a while back, where and then when it's looking for a value, it'll keep going down the prototype chain until it finds one, or until it reaches the end of the chain and says, I didn't find that. So I'll be able to highlight that here just a little bit too, right? So let's add a property here. I don't know, is for wheel drive, and we're gonna say it's true. And if I create an object off this truck, so I create a truck, and it's going to be a Ford, it's going to be an F-150, and I don't know what year it's going to be. It's like this year, why not? I'm going to add a bit up here too. I'm going to add a bit up there, so we'll see that get printed out. And then I'm pretty much just going to steal it, put it down here, print this same line, except I'm going to replace all these my cars with my truck. And now if we run that, we should see that the Mazda 3, it doesn't say it has four-wheel drive at all, whereas the truck says true. And that's because this property doesn't exist on anything that's created the vehicle object. This is directly on the truck object. It's not on the vehicle. Whereas by calling this super, we actually, again, this gets into that complexity. The properties, the make, model, and year are also not on the truck object directly. Calling this super and everything else puts those properties on the vehicle object that you inherit from. And it is able to read those. So we could, let me see if this will work. I'm gonna test something. This isn't, that's not the right syntax, is it? It's like this. I think that's correct. Let's see if this works. Not. Shouldn't be like this. I'm gonna try it. Read make of undefined. Oh, yeah. So maybe I may have something wrong about how it works. Just attaching it to the other object. I could be wrong there. It's not that important anyways on that. So I want to highlight a couple other things to show what it means to use this inheritance again. This is probably, you guys haven't really been working with this, so don't worry if this is pretty stale for you. But you're going to need to know at least a little bit about basic inheritance. Most React development only ever extends one thing, which is React or component, I think. So most of your React development will only ever extend one level down, which is the base React component logic. But that does give you some powerful things. So for example, I've got these console logs here where I'm printing something out. Well, we had the example, on our stuff here where there was an about method on our objects. So instead, I'm going to change that and put an about directly on our objects as well. And this will basically get the console log. And this is going to make my life a lot easier too. Because, well, first off, we're going to get rid of the four-wheel drive bit. Because it would be silly to put that on the car because it doesn't have anything. And then instead of my car, since this is attached to it, I can say this. So now instead of having to rewrite this about if I did multiple cars, I can just use it. Oh, I'm not calling it, right? Let me change my code here. And actually, I prefer not to console log in my method. So instead, I'm going to return string and console log it down here still. I prefer to keep that down here. Just sort of nest it. So let's see. Now we should say I drive a 2007 Mazda 3 because we got rid of that logic on this. But we can redefine this about on our truck, for example, and add in, well, this logic that checks about four-wheel drive. I've got a couple things wrong here. Oh, wait, no, that's correct because I'm returning it directly. And now we can console log my truck.about. And this about basically hid the other about, like it covered up this about. So when I was talking about that prototype chain, it looks for, oh, where's the first place that I have an about method to call? Oh, it's on the truck itself? Okay, I don't have to go any deeper to call that. Now you could, again, this is where I may screw up the code. This may not work. We will find out. Let's try it. Undefined has four-wheel drive, true. Okay. So that is not correct. Let me see. Maybe this is gonna work. Okay, there we go. So now we got, you notice the undefined, right? So apparently that doesn't know, what I'm calling here doesn't know about my context, the about. But that's why before when I tried to reference stuff also didn't work, I guess. But now that third about, this about call was able to call this one. I just had to go a little deeper, and it's because of the way that these class things work. It's again, it's sort of complex. Now we can do a bit of magic. I think this will work. Let's try it. Don't worry too much about this. These work. Oh, they're not gonna work. Did I call bind wrong? Maybe I called bind wrong. Oh, I need to do it this way, right? Right. Yeah, I'm gonna try this. Try that. Syntax is a little weird. Ah! So even though the about didn't know about the before, that's that aspect of what I'm talking about. You can change the this context of something dynamically. So before I was calling this about down here and it didn't know make, model, or year, but all I did was tell it, oh, your actual this context is the truck, which has a make, model, and year, so you're good. Use that instead of what you would normally use. That's the magic that JavaScript lets you do, which is really cool, but also really, really confusing for people who've written in other languages. People completely and thoroughly lost now?
I have a quick question.
Yeah.
A class that's been extended, properties that you add on to the constructor beyond what was on the original class that you are extending to?
Yes.
Can they only be Boolean?
No, they can be anything.
Okay.
They could be anything.
So
You could even change values, right? So yeah, you could say like, I mean, yeah, we could have this dot full information or something, you know, and we could just make this whole string together, right? We could say, oh, make, model, year, and that's, you know, just another property. And that's fine, right? Console.log my truck dot full information. So I just added a different property. You can add any properties on there.
So if you wanted to like add something that showed what color it was, would you put in the constructor line make, model, year, color, and then you still have super make, model, year, and you put this dot color equals
Yes.
color?
That's exactly how you would do it. Yeah, exactly. So yeah, if we wanted to add a color here, you would still call the super like that, and then this guy instead would be color and set, you know, the color to what you passed in. And then down here, you know,
After 2019,
yeah, you could do like a color here, you know, you could put it in here. Then we would have to pass it in, you know, and this is a Ford, so there's only one color. Yeah, so you can add extra parameters, but yeah, you would want to do it that sort of way. That's a good question. Any others? You'll encounter a lot, again, of this, but it's going to be very shallow. We're probably not going deeper than one level of extend for the most part when we do the React stuff, because we're going to be extending the React component. But that gives us a lot of built-in capabilities when we do that for React components. Yeah, a lot of arrows. Okay, object literals. We have done, oh my gosh, yes. I'm not gonna talk about what's really being shown here. You can do some really complex stuff where you can put new computations on the left side of an object literal, but we've written a lot of object literals at a basic level. That computation bit, don't worry about it. So I'm gonna skip over that. I don't think you talked about it, but right now I'm gonna take the opportunity to talk about one of these other aspects, which is a new shorthand that exists, which is really handy to have too. So let's go back up to this car factory, for example, and we pass in a make, a model, and a year. And then we have to write this almost like boring, like I'm almost frustrated, right? Year, make, model. Well, if my variable name has the same name as the property I want to assign it to when I'm creating an object literal like that, I can get rid of that, all of this on this side, and they're equivalent. It's doing the exact same thing. So this is a nice little shorthand where it's saying, oh, return an object where it has a make property that's just the value is whatever the value of the make variable is in this context right now, right? And it seems almost a little, what? Right, it seems a little too easy. It seems like, why would I do this? But you'll find that this is a very, very commonly used type of pattern where you're frequently just create another. And the reason is you usually wouldn't do something like this where you grab everything. A lot of times what you might do is, oh, now I'm going to add a couple extra properties. Or you might create a new object that says, oh, I don't want that property of it, but I want all the others. And so I'm able to create a new object that stripped something off really easily and gave me back all these other properties. So that's a like object literal shorthand for creation stuff. That's an incredibly useful ES6 feature that, yeah, it seems almost too simple, but comes in handy all the time. In fact, I would argue that the simplest ES6 features are the ones that I use the most. The next one that he talks about on here, which we've been using already all over the place, and that's because Node had support for it much earlier, so we were able to leverage it, is just template literals, right? Those are the ones that are written with the backtick. And then you can put variables. You can also even do multi-line, and it'll properly keep the multiple lines in there. But you can put variables inside of them using this escape notation, and it will put in the variable, the value for that variable. So we've been using those a ton, but those are actually an ES6 feature as well. It's just one of the ones that everyone adopted really quickly in their engines because A, it was easy to implement, and B, it was really, really useful in terms of just fitting the pattern that you're used to writing with other code. Any questions on that? Shouldn't be, we've been writing those forever. All right, so the next one is another really handy one that we did encounter, I don't know, like a couple weeks ago, and that's destructuring. So I think it's only array destructuring that was actually in ES6. I can't remember which one. There is object destructuring too, but I think that came later. Or object spread syntax came later. I think array and object destructuring were both there, but object spread syntax came later. So destructuring is just a really handy way to create variables and assign them to items from an array or an object automatically. So in this case, it's creating two variables, A and B. And A is 1 and B is 2. So it's a really useful way to get things out of, in this case, an array and also objects.
How is that different from doing a split on?
The difference is you can give stuff meaningful names when you do this, whereas split is going to, well, split doesn't exist on an array. Split is a string thing where you're going to split it into an array. But yeah, what you can do here is instead of having an array and having to refer to stuff using, say, indexes, if you know, oh, I care about these two values out of my array, I can grab those. Oh, I just care about the first value, I can grab that. Or in this case, you'll see like, oh, here's 3 items in an array. You can actually just leave an empty space here. And then A is 1, B is 3, and it assigns nothing, 2 to nothing. And I guess I probably don't use it with arrays that much in JavaScript. But I use it very heavily with objects. What? I said I don't use it that often with arrays, but I do use it very heavily with objects. So object destructuring is really, really handy. And that's because here we've got, oh, okay, we're going to get A and B, and we have local variables A and B that got assigned from this object. It doesn't look that handy at first, but let's go back for a minute and just rewrite some of our code. Again, it won't be something that powerful, I guess, at first, but let's rewrite some of this code in a interesting way for like our truck, for example, right? Is you were talking about different ways to make some of this a little easier to work with. you could, instead of passing these in as individual values, you could maybe pass in an object. Oh, I'm going to pass in an object that has a make, model, year, and color as my only parameter to my constructor here. And obviously I can't write it this way, right? I need to give it a name, right? Call it like properties is what we passed in. Okay, well, here I can do like properties, and it won't make sense. It's not really saving us a lot here. But if, okay, I need to call down to my super, properties, year, and then this could be properties.color, not truck color. Then everything, oh, I'm not calling it correctly here. When I create my truck, I need to pass this stuff in, right? I need to pass in a make, a model. So now I have to give them names, a year, and a color, and close my object. Let's see if this worked. I probably screwed something up. Huh, I think we're working. I'm gonna get rid of that line. But so right now it's not necessarily reducing our work, but you'll definitely encounter times when it will, because it's easy to pass around an object all over the place and work with it. And then we can start doing some of this object destructuring here that might make something easy, right? Where we could say like var color equals properties. And now instead of properties.color here, we can delete all of that and just assign that to the local variable color that we just pulled off of our properties object, because you don't have to grab everything off of your object. You can destructure just the pieces that you need. So, oh, we only got the color for this local logic. I don't actually care. And now if I rewrite some of this again, let's take this whole vehicle bit and let's just pass properties into it the same way. So instead of that getting 3 separate arguments, it takes one argument, which is an object with a make, a model, and a year. And I need to call it correctly here, but now it made it really easy to call it here. I just pass my properties on down, because it's not going to matter, and I need to fix it here. Oh, I can do some destructuring. That's the only line I needed to change in that after changing it to an object. Now it'll still work. So I got to pull the piece off I cared about in my subclass and use it, and just pass that whole object back down to the next thing and let it pull off the pieces it cared about and use them as well. So that's where destructuring can come in really handy, is you can pass an object all over the place and pull off the bits that you care about in specific places, as opposed to having to know all of these details.
Does order matter? Like in your variable you had, you know, make,
No.
model, year, could you do model, year, make, and
Yeah. Yeah, it doesn't matter, because an object doesn't have, well, object literals technically have order now, but there's no defined order to those. It's just checking for something that matches. Oh, hold on. Oh, wait. It's already later than I thought. So this is where I use it a lot, is this sort of object destructuring, which comes in really handy to pull off the pieces that you need. I don't necessarily use that array destructuring as often. And then you'll see here, if the object doesn't have a property, when you try and pull it off into a value, that value or variable just gets undefined. So it doesn't actually hurt if that's the case. Destructuring concept makes sense in terms of using it? Yeah, a little bit. Yeah, it's one of those syntaxes you always have to look up the first, like, I don't know, 30 times you do it, and then it starts to be something that's easy, but it's a nice little shortcut. It's just one of those syntactic sugar elements, because this is really, all this whole line here is sugar for just saying var model equals properties dot model, you know, etc. So there's nothing magic about it. It's just because we are properly lazy programmers. And we create a lot of tools to make our life easy. What do we have here on this one? Get person. This is just doing some more destructuring. So nothing new there. All right, next one, function arguments. I sort of want to go back to my old truck now. Was there a question or? Okay. Yeah. Okay. Function arguments. I almost want to go back to my old declaration of my truck here, but we'll just use a different function for this. We'll put it on the car factory, for example, which is you can now give. Oh, this is interesting. This syntax is wrong. Yeah, that syntax is like wrong, I think. So you can now give default values to properties in your function declaration. So here on our car factory, let's say we're going to add a color as well. And we're just going to add that on here, right? Let's see. I'm creating my car 1. Let me steal like this line, even though it won't be exactly what I want. Do a little work on it. You go back there. I don't care about 4-wheel drive. But I do want it to have a color. And I want to get rid of this return stuff, right? All right, that should be good. No, that's not legit. All right, so let's see that. I have an undefined. Oh, because it's trying this, right? This is outside of here, so I need to do, hold on. Maybe. There we go. So now it should print out. But we have undefined because we didn't pass in anything for color. Let me minimize these guys so they're not in our way as we're looking at this. We didn't pass in anything for color, so it by default gets undefined, right? However, you can now do default arguments by just saying that something like black or gray. And if we come down here and we look at this, now I drive a gray 2007 Mazda 3. Because I didn't pass in a value for that, it gets assigned whatever I have on there by default up on the function declaration. This is also really, really handy. I use this a lot. A couple of things to remember when you're working with these. Anything that has a default value should come as an argument after things that don't, because you can't not pass an argument, earlier argument, and then, so you can't have like, oh, I only, you know, if I put a default value for model, there's no way for me to pass the year in and not pass in a model, which means that if this got a default, this would be guaranteed to be undefined because I didn't pass anything in for any of those, right? Unlike some programming languages, JavaScript doesn't have named, you can't invoke a function with named parameters. So order is the only thing that matters. So if I did that, I would need to put like a default value here as well. And then you could optionally pass in make, or make in model, or make model in year, or all four. It doesn't matter. Oh yeah, you could, I mean, you could change this like on the object. Just like you could anything else, right? I changed it on the object. Or you could also, if you're saying like up here, like if I wanted to change my color, I'll say my color is blue. Let me get rid of this line here. So you can do that, and it's just fine. And you could even, so we used to, the way we used to do something like this in JavaScript, and you've probably seen some of this, we've probably written it, is we used to have logic that would be like this. Bar color, let me get rid of this right now. Oh no, I need it here, right? I need to have color. So we used to have logic that was really sort of ugly, that would be like essentially color equals, you know, I don't really use a lot of this syntax. So let me do the bigger syntax instead, so I'm not introducing you to something that's this ternary, because we didn't use it a lot. If color, so if it's not falsy or whatever, then we're good. But what we want to say is if not color. So if it's a falsy value, so undefined, null, false, empty string, oh, then color equals gray. Like that's how you would have written that before, which is sort of verbose. It's a lot of ugly logic there just to get a default value of gray versus being able to do this and rely on the invocation to do that for you. Any questions on that? All right. Yeah, I don't know. This is a little bit, I think this is just wrong syntax on here. There's some other stuff that we won't talk about where you can do some stuff like you can actually sort of inline, I guess I'll show it, but just because you might encounter it, but you can inline something like this bit of logic here. I think this will work. Look, sometimes I don't even know what I'm doing. Where it knows like, oh, this first argument is properties. I can just say model make year, I think. And that's destructuring it right there in the function definition. And it will create those local variables. So that's like, I think what was being trying to get at with that other thing, but I think the syntax is just wrong. I'll do that stuff sometimes, but probably not as often. The reason you might do that is, let's let me put it all back that way. I'm doing this. The reason you might do that is because see, there's going to be a problem. It's not as easy to do with what I want to do. So this is why a lot of times why I'll write it this way. But if you wanted to have a default value for something, you can do that if you like destructure up there in the creation. You can also do it like right here when you pull something off, where I think I don't know, let's go with a different color. I think that's the syntax. This is one of those syntaxes I never remember off the top of my head. So we're going to find out if it's correct. Oh yeah. So you can say like, oh, if this would be undefined, and it actually is green. Otherwise, again, if we go back and we pass in a value, then it should not get that green, but that's not that common for me to do. This one is very useful. This isn't actually called this function arguments. This is what's known as array spread or whatever. So this syntax is really handy, where what this is doing is taking all of the arguments of the array. This is a little bit like, I don't even know what to say it's like. This is going to take each one of these array arguments and pass them in, or each parameter in the array, each index, the value in each index, and pass it in as individual arguments to the function. So I'll show you this You won't necessarily use this all the time, but let me show you real fast what this could look like, I guess. So let's, I'm gonna create a array add. And instead of, let me see here, nums, dot length. Something wrong here. Oh, no, wait. Length, 1, 2, 3. This is doing the backward. This syntax is wrong. Again. This is not the right syntax. Trying to capture what he was trying to do there, but I'm gonna skip that and revisit it maybe at the end. We'll see. Because I was gonna show spreading an object or something, but and I think this might be using it correctly. Okay, this would be using it correctly, yeah. So this is an example of what I was talking about. So here it declares a function that says total and it just returns, I don't know why it says the log, I guess it's just outputting it, right? Of X, Y, and Z, so it's adding up all of those. And so total takes 3 arguments, but you could also, this is the old way we used to do this, where you would have to use apply, because apply will do the same thing. It'll take an array and make those the individual arguments to the function. But now you can sort of consolidate that with like ... And there's very limited cases where this is useful. There's a few of them, because there are some functions that exist in JavaScript where you just need to, it can accept any number of arguments, for example, and it's a pain in the butt if you have an array of arguments and you want to pass them all in to have it work with it correctly. But there's not a ton of places where I would say you encounter that. That's this sort of spread syntax. And then you can do it with objects as well. And that's pretty common in React. And that's something that is not part of ES6. It's definitely later. But let me see if it'll work with the version of Node I have on this system again. I don't know if it will, but we're going to find out. So that spread syntax I was talking about, if, say, we wanted to only pass an object in to this vehicle with just these properties, because right now the object that we pass down here also has color, but we're never using it. We could do, let me see if I can get this right, ... like other properties. And that will say, oh, pull the color property off of this properties object, and then everything else put in another object, spread those into this other object called other properties, and then pass that down here to this guy, and let's see if it works. All right, so the version of Node I have does support that. It used to not. So it's actually creating a new object that doesn't have the color property anymore, just the year, make, and model. And that ends up being really handy with React, because a lot of times you don't necessarily, like I said, we don't have a deep inheritance tree, but a lot of times when you're rendering stuff, you guys, most of you have been doing like the HTML course, right? You've got div inside of a div, and then a span, and then like nested like 5 layers deep, right? So a lot of times when you're writing React components, you have a React component that renders React components inside of it that renders React components. And you might need to pass properties all the way down through there, but only some need to go down. And so you can strip off the ones something higher up cares about, pass the other ones down, and create a nice hierarchy of what you're working with. So you'll definitely see that in React code and when we do stuff, because React are the people who help push that getting standardized in the first place. All right, this is the last real concept I want to talk about. They call it scope in here. I want to talk about the 2 new ways to declare variables that we haven't used much in class, and that's let and const. This isn't anything too complex at a base level. So we'll go to our math here. Basically, anywhere you have a var, you could switch that to using let, and it's more or less going to work the same. So if we ran our tests now, they should still pass because we just switched those over to using let. The key aspect and the reason why it talks about scope over in this other tutorial, which we'll see, is the way var and let, or let and const work. They've got a couple things, about 2 or 3 things that make them distinctly different than var, especially let. Let and var are close. I'll talk about how const is different as well, because I don't think that's brought up at all in here. But we've discussed scope before, right? A variable's in, oh, it's declared in this function scope, where you have global scope. So in this example, right, foo is global, fad is global, bar, well, because we didn't give it a var statement here, it's implicitly global scope, which is something you want to be very careful with. That's a sort of a quirk of JavaScript as a language, but because we did var baz here, that's in this function scope, right? None of that other than this weird implicit global, which I haven't talked about because you should always avoid that, should be new. But here's something that's different than a lot of other languages. Again, if you're familiar with other languages, which is with var, the only scopes that really exist are like function level or global. There's not, so a lot of other languages have what's known as block scope. So this if block here, we're declaring a variable foo inside of it, and then we're declaring a variable baz outside of it, right? But both of those exist inside of this function scope. So they're accessible anywhere in that function. Although if you tried to read foo or baz before they're declared, you'd get undefined, but they're both accessible there. So, yes?
Is that the reason why all like before like they're you do that with classes?
I don't know. I think so, yeah. That's known as hoisting. So there's that's a weird aspect of JavaScript as well, which is, let me create another file here. I'm just going to name this guy. Where are you? What? Higher. Yeah, but where did it? It's not like down here. Oh, maybe I didn't save it at all yet. Okay, that's why. So let's save you, and we're going to call you scope.js, just so we can work with some stuff here, right? So if I create, dealing with very traditional JavaScript stuff, a function, I don't know, we'll just call this function, or we'll call this var hoisting to sort of show what we're talking about. And we're not passing anything in. I don't care. So at the top of this, again, I don't recommend logging stuff in your functions, but this is just tutorial's sake. I'm going to console log foo. And then I'm going to declare foo. And then here I'm going to log it as well. So this is very, very simple right now. That's all that's going on in this. So node scope. What you'll see is we got undefined printed out. It's a little low on there, I'm sorry. And then bar. And in most languages, this line here would have thrown an error. That would have caused an error because we haven't yet declared foo. So how can I try and refer to it in this function scope? But in JavaScript, this line here could, whenever you're doing a var, basically what it does is it actually ends up converting it to look more like this. It's var foo equals bar down here. So that's what's known as hoisting. It hoists the declaration of it to the top of your scope of whatever scope you're in. It does the same thing with functions or other stuff, but it's undefined because it can't hoist the value setting. All it can do is hoist the declaration. Now, this gets into one of the differences between var and let that I was talking about. It said there's not a lot, but let's do a let hoisting. And if I declare foo using let, and I will log this out, let hoisting as well. Now I'm going to get an error. And that's because let, any variables declared with let are not hoisted. Their declaration is not hoisted to the top of your scope. They're only declared when you encounter them in that line of code. So if I got rid of this, we should work, because now we're only trying to refer to it after we've declared it. That's one of the really three differences between let and var. One of the other ones is with var. Let me do this again. Let's add another one here. Var foo equals foo bar console.log foo. All right, let's see what happens here. Let me get rid of this guy. Get undefined bar and foo bar. Now if I try this here, and I'll just change these two lines so we're only printing out the one. It's going to yell at me and it's saying foo has already been declared. So one of the other key differences between var and let is you can't redeclare a variable using it. So that's one of the other key differences, is you can reassign it, but I can't say let foo a second time because I already declared foo. So that's a bug with, or throws an error with let, where it doesn't with var. I would actually generally encourage you, once you start writing the React code, to just use let for the most part as the way you declare variables. You'll see a lot of documentation that suggests just using const. I would just encourage you to not get into that too much. There's a reason for const, but I think it tends to be oversold as doing something positive, whereas I think it adds complexity to your code. And we'll get to const in a second. So the third thing that makes let and var different is block scope. If we go back here, remember this var foo, that exists in this function scope. Let and const are block scoped variables. So what that means is if we take this logic right here and we say let y equals 2, that only exists with inside of this if block. So the nearest block that it's declared in, not the full function. So that's very similar to most other programming languages that declare variables using block scope. But if we did var, well, that's still function scope, even if it's inside of that if. So what that would mean is if you tried to refer to this y down here after you've exited that if block, you'll get an error because that variable doesn't exist. But you could, I believe, I think you could do a let down there as well as in here, because those would be different scopes with the same variable name. We could test that if we want, but I think that would be allowed because it would be in, as long as they're not in the same scope, it's not a redeclaration. All right, so let's talk const for a minute. And then I'll quickly show you the modules, or the difference between what we've been doing with modules for CommonJS modules in ES6. It's not that big of a difference relative to everything else. Const is very similar to let. I'm going to steal this, use it a little bit. Oh, that's going to throw an error right now anyways. Let me make this not an error. So we'll just do const declaration. And so you declare a variable using const, like const foo equals bar. Let me put this let one here again. So here we can, oh, not let, but if I redefine foo to say foo bar, so I didn't, or I just reassigned it. I didn't redefine it, right? I didn't call let again. And I log that. Let me get rid of all my clutter up there. in this. Let's see what happens. I get bar and foo bar, right? Because I can change the value of food anytime, just like any normal variable. That's me just changing the value. With a const variable, if I try to change the value, like I would do here, oh, I'm not printing it out. See this? Should throw an error saying I'm trying to assign to a constant variable. So I can't change the value of this after it's been declared with const. That's really what that const does for you, is it prevents you from reassigning a different value to it later on in your code. And so going back to saying, you'll see a lot of that, there's a lot of people out there who say, oh, if you never change the value of a variable in a function, you should declare it using const. That way, you know, you're just safeguarding. You see a lot of people say that. In fact, there's some coding guidelines and other things that like, oh, this is never redeclared, you should do const. I tend to be against that because if you ever do decide to reassign it within that function, now you have to go back and change your declaration, which I think is a little silly. I think const should be reserved for if something is a constant. That way it has a real contextual meaning. So like if we were inside of here, if we had const pi equals like 3.14, like that's a constant. That value isn't changing, you know? So that to me is a good use of it, but I don't use it just for standard variable declaration. Plus it's 2 more characters. So, you know, I'm not gonna type that out all the time. That's crazy. All right, I think that's, oh, there is one trick with const too. One thing that's a little tricky about it that's going to be, that will trip you up when you do encounter it. So that's that you can't change what the variable points to, but remember there's a difference between like reference types and value types. Like a string or a number are value, so if we compared them, we're comparing the values, but an object or an array are references, right? So if I declare this foo and I say this is equal to this object, and I'm going to have some properties on here, bar of bar, and now I can do like console.log foo.bar. Let me get rid of these lines real fast. I think I can just console log foo. I think it might show me the whole object. Let's see what happens. Okay, so we see bar, bar, right? I can, however, I can do foo.foobar equals foobar, and that's not a bug. And that's because it's still pointing at the same object. What it's pointing at didn't change. All that changed was I added stuff to what it's pointing at. So that's a dangerous thing about const too, is you'll think like, oh, they can't add anything to this object because it's constant. No, I can't change, I can't do this. I can't do foo equals a new object because that would change what it's pointing at. It's a little tricky, but JavaScript isn't the only language that operates that way. Just about any language that has referential or references versus values actually has that same got you in it. Just a lot of them don't necessarily, it's not as obvious because you don't work with stuff that way, the same way that you do in JavaScript. So now this is an error because I changed what I pointed at, and that's because it would be pretty hard for the language to shoehorn in after the fact. The reason that that works that way is it's hard for the language after the fact to have the ability to say, oh, you declared this reference type with const, then I need to lock it so that nothing in that can change. That would be a fair bit of complexity for them to add into the language. Whereas doing it this sort of, you just can't change what it points at is simple for them to add. But that will trip you up where you're like, I thought this was a constant. How did it change? Oh, yeah. Any questions about let and const? Those are the ones that you'll probably encounter more than anything else. Again, I would suggest that, I haven't checked Cloud9. think the version of Cloud9 on, or the version of Node on Cloud9 supports let at least, because let and like template literals are about the first two things that Node supported. But as long as it does, I would suggest to switch over to pretty much just declaring variables using let as just a sort of good practice, because it can prevent some very small minor bugs in your code that you could have otherwise. All right, last bit for today is just the export syntax, right? We're already working with, let's go over to our math here, right? Here we've got this module.exports where we export an object for things. And then inside of like our math tests, we require it to bring them in. This is just a slight change in syntax. Instead of module.exports, it's just export and then your object name. And you'll notice they're using that object shorthand that I referred to earlier, where they didn't say foo colon foo and bar colon bar. They just said foo and bar, and it automatically assigns them to the variables in that scope that match. And then you can import using that same sort of syntax. And this is using that object destructuring syntax, right? Because import from app is actually getting you an object. This is just saying, oh, create the variable foo destructured from the object I got back from app. So that's going back to that destructuring syntax where you could, like what we used here, for example, where we destructured and got the property names out. That's all that's being done here, because app is actually returning an object, and this is just destructuring into a variable foo. But the syntax is a little cleaner using this import and export. We haven't used it because this is one of the last things that browsers or Node or anything else has added support for. The common JS is much more supported in Node. I mean, it evolved with it. I think like the latest version of Node maybe supports this. We'll use it when we get into React, because we will be taking whatever JavaScript we write and actually compiling it to other JavaScript. So we'll run it through a tool that converts it to JavaScript that your browser can understand. So that means we can use all this newer syntax even if the browser doesn't support it, and it'll convert it down to syntax that your browser supports. And if you ever want to play with that, a really awesome site, if you've never been there, is, oh, I have this full screened. A really awesome site is just Babel.js, because that's what we'll end up using. Babeljs.io, because they have a. This should show me. Come on. Yeah, they have. This is what actually gets used for the most part under the covers to convert newer JavaScript to older JavaScript, if you will. And let me see here. I don't know if it'll work for something as simple as this. Let's see if that works. Oh, I may have to change some settings or something. Let me see what I can do. Environment preset. Enabled. Oh, see, there you go. Now it's showing you what it converted this let foo equals into. It looks like that's actually what gets built for if you say that I'm targeting Internet Explorer 11. So it converts it into something that's similar. Or if we, let's go to our, let's just grab one of these, right? Let's grab my class vehicle here. You can play with this stuff. And this is the code that gets output that's valid older JavaScript that's comparable to this. A fair bit, I mean, you wouldn't write it this way. You would write it in a different way, but a fair bit of complexity there, right? Pretty ugly. And then if we, if we went back and we did that default values, right? Function car factory. All I want here is make model year, and then I'll do color and give it a default value. And you can see that this is what it actually outputs, which is a little more complex than what I wrote when I did mine, but that's because it's being, it's sort of handling some other cases. It has to be more generic. You can't optimize the way to write something for just what you're doing. But this is a really fun tool to play with too, to just see if you're like, oh, that newer syntax, what is it actually like? You can see what it gets built down into. But we'll be leveraging this just without calling it directly under the covers when we're building React apps. So we'll be able to do this newer version of export and import and ES6 syntax and not worry about whether the browser supports exactly what we're working with there. And I'm not going to talk about generators. That's a complex topic. That's worth an entire class itself. That's worth multiple classes. So, oh yeah, and then there's this great site, which at this point, everything should look really positive. Come on. Maybe if I make this full screen, I can get to it. I can't. All right, I'll just pull it up here. ES6 support. It'll be the top page, I know. So there's this really great site that sort of tells you what newer versions of JavaScript, what features are supported by different browsers. And if we looked over there, we'll see that, like, if we get into the actual browsers like Firefox and Chrome, you know, just about everything's green. Just about all the new features are supported. It's not until you get down into IE11 that you see a lot of stuff that isn't supported. And you'll notice we didn't talk about everything that's new in JavaScript either. All right. Are there any questions on this? This is, again, this is just sort of a crash course on this stuff so that you guys will be familiar with this syntax. You know, if you have any questions when we're actually working or questions after this, feel free to hit me up. Oh, yes, thank you. I appreciate that. I do, after talking with Daisy. Let me pull up, what do we have? What? Let me see what we have here. We've got, the plan right now is, because I'm going to be on vacation this entire week in July. What? No, I'm going to be on vacation the whole week after the 4th. So I'll be out of town. Yeah, so right now the plan, barring anything changing, will be for us to get started the week of, I guess, the 14th, probably going with the same days. I don't yet know. Please give me feedback on preferred location, because I didn't talk with Daisy about whether it would be here or the Frontier, but if people have a preference, the more I hear, the easier it'll be for me to push something.
I just would like to point out, as like baseball, like starts getting worse and worse.
Yeah, I know we've got these different, I know we've got competing needs there, and so that's a challenge. But the more I get to hear from people, the more we can try and meet, you know, whatever we can in the best way possible. So I didn't follow up with her on where yet. But yeah, the goal will be to start this week, probably doing the same sort of schedule that we have. Since there's going to be a gap, because there's only about, I don't even know if I have a full week of content. It might just be working through some stuff for this. Since there's going to be a gap of actual class time, then I'll be pulling up some resources to help people either get familiar with React, as well as just continuing to work on general JavaScript skills and ecosystem stuff in the meantime, and encouraging you to sort of build into that or go through that as well. If you really are interested, the easiest thing to do, and this will be one of the things I would suggest anyways, is it react.org? I don't know if it is. It's not. React.js, all right. There is a very simple, let me see here. I think there's like a very simple first example or something, I can't remember, of, they've changed it up a little bit. But there's some sort of simple ones if you just go straight to the React site. This one is much more complex. Don't dive into that yourself. That may end up being what we actually work through collectively. So they may have, oh, hello world, I think, is just about the simplest thing. But they may have something else in there. They used to have a really, really simple one. And it looks like maybe they've changed it up. Yeah.
How long is our break? Our break is that 1 week, so it's the week of the 8th.
No, we're going to, well, I mean, I only have like a week probably of content left for this right now. And that's just more putting some things together, you know, like, hey, let's talk about concepts collectively, maybe work through some of these bigger examples. So what? I know, and that's the concern, is I don't want people to, so I want to, that's why what I'm gonna be working on is some more hands-on stuff where instead of necessarily having like in-class time, where we're like, there's any instruction, what it'll be is like, here's some exercises for us to be working on collectively in that time frame to continue to practice and continue to build up that skill set. And I didn't talk, that was another one I forgot to follow up with, but I wanted to talk with Daisy about if we can have time where it's like, okay, it wouldn't be in a classroom like this, it would probably be at just their offices at the Frontier or something, but we might be able to say like, let's just have some like set aside time where people can get together and work together through these exercises as well, right? Where it's not like instruction, it's not teaching so much, but time where people can be there. And then I could be there, you know, working on getting the material refined as well for the next one, but also answering questions if people need it. So that's, yeah, if I didn't have that vacation at that awkward time, you know, we would get started earlier, but it'd be really awkward to start and then be gone for a week right after we get started. So.
How many more classes of this level? 2 or 3?
Yeah, just 2 or 3, yeah.
My birthday's
And Daisy also talked about for, you know, I don't know who all is going to be, you know, people should definitely hit her up or hit her and Dan up about the internship program. I know she's heard from some people, but we were discussing the fact that with that long break and the fact that some people are going to be, you know, that's stretching out a long time for people who are doing this, that we're talking about potentially having people get into that internship while that course is still going on, so that there's not, you know, this huge gap between when we started and when people have the opportunity to get into that. I don't know if we refined all of that. I'm sure they'll follow up with more information on that, as I really don't. I don't know what's going on with all that. That's outside of my scope. So, all right, that's a good question. Thank you so much for reminding me about that. All right, and in the hangout.